This chapter is called functions. So what is a function? You need to learn what is a function first. So function actually it's a relationship between two variables, right? Usually we use x to represent the variable, then use y represent a function. Actually, these two variables, one x is a basic variable, y is depend on x, right? This is define a relationship. So if we draw a two set, this we can use a set to describe this two. Suppose this one is set x, this one is y. If you have all the elements from this variable x1, x2, blah, 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 this one is y1, y2, blah, blah. A function actually set up this relationship like this. So then when this relationship is a function, you know that for every x, you should have a y responded to it, and for different x, you can corresponding to the same y allow this, but don't allow you the same x responds to the different y. If you have this happen, that's not a function, because this one it's useless. This one, like when you go to the supermarket, you try to buy something. You know, if each item they will have show you the two different price, how much you need to pay, right? If the same item, like suppose this one like tomato, they show you this one it's $1.5 a pound. You also show you this one's $1.8 a pound. So then which price you need to pay? That's meaningless, right? But we allow the different x respond to the same y. So that means if the suppose x1 represent tomato, then x2 represent to like a pen. They have the same price for each one. Suppose that's all equals $1.5. This respond to the same price. That's fine. Okay, for the different y, give you the same price, same y, that's fine. But we don't allow the same x corresponding to the different y. That one is useless. So this kind of relationship we excluded from the function. So when you try to check if a plot is a function, it's a very smart way and shortcut. You just draw a vertical line. Suppose this one is x, this one is y. Then if you have a plot, suppose this one like circle here, then let me draw this one better. Otherwise, it looks as so. Now, if you draw a Cartesian line like this, then if we draw a circle here, then we ask you this plot circle is this function. You just need to check, draw a vertical line anywhere to check if how many intersection points you can have. So when you draw here, you get two intersection points with this plot circle. So that means this circle is not a function, because we have the same x here, then we respond to the different y. This is y1, this is y2. They're different. So that means this plot is not a function. If you try to make this one function cut half, if we just keep this semicircle on up of the x-axis, that will be a function. Or you can keep the lower part of the semicircle. That also will be a function. But if you have this whole circle here, this one's not a function. Okay? So now let's see. Here we define a function. Then now here for fx equals 2x plus 3, this one is a demi-variable. Here x in this function called a demi-variable, which means it is essentially a placeholder. When we put a specific number in our machine, we place x with that number in the equation this, then to determine what is the machine output. For example, if you plug 5 here, use 5 to replace x, then get 2 times 5, then plus 3, then give you 13. Okay? So now let's see a domain. When you research a function, you need to research what is the domain. Domain and range. Domain of a function, that means consists of all the values we are able to input to the machine and get an output. So that means you need to give all the number of choices for the x, for this dummy variable. Now let's say if for this one 2x plus 3, you can choose any integer as x. So that means this domain for this function is all real numbers. But the output, that's called output of y, that's called range. All of the value for y we call range. This range for this function is all real numbers. Okay. Now let's check this one. If this function fx equals 1 over x minus 3, the domain definitely x cannot equal 3. If x equals 3, this one is meaningless. So this function domain is all the real numbers, but not 3. So range of this number, that's also all the real numbers, but not 0, right? Because this one is 1 divided by x minus 3. You cannot make this number equals 0. Okay? Except 0. Now let's see these examples. 16.1. State whether each of following describes a function or not. For each that is a function, describe the domain and range. Okay, so we'll give you a relationship, then ask you if this one is a function. Give you an input, output, then ask you if this is a function. If it's a function, you give us what is domain, what is the range. Okay, now let's say first one, A. Input, that's name of a month. Output, number of days in that month in 2005. Is this one a function? Everybody answer this question. Then send me a private chat. What's your answer for this one? Input is the name of the month. Output is number of days in that month. Then in 2005. This one is a function. Why? Because the name of month, you know, that's if you use a full English word, they're all totally different, right? Name of months, that'll be January. Even we use the 3 letters, then they all should be not exactly the same. They all should be different. Say January, then you maybe have 31 days. February, maybe you have 28 days. Then March, maybe also have 31 days. So then this you can know all each name of month, then respond to a specific number. You did not have that kind of thing happen. That means, suppose January, you got 31 days. You also got like 29 days. This one never happened, right? For January, usually you have 31 days, right? So for each month, how many days you have, that's fixed. So then, and also for each variable, each month, you definitely have a number respond to that month, right? So then, if we draw a plot for this relationship, then we'll get like this. Suppose we use here, this is January, this January, then February, Here, suppose this 31 days, this 31, then 28, then 31, blah, blah, then like this. So this one, as the shortcut I told you, if you try to check if this is a function, you draw a vertical line, you can never get the same x respond to the 2 y's, right? So now that means this one's a function. Now, after we determine this one's a function, we need to know what is the domain, what is the range. So domain, that's all the choice for the variable x. Then for this case, that's all these 12 months. Name, January, February, you can write like set. The domain, usually we use the letter D to represent. You write D equals, then use this bracket, right? January, then February, then March, then you write all of them, then use a bracket, close it. Then this one's domain. Then what is the range for this function? Range, then you can only have like 28 days, 30 days, and 31 days, right? So this year is not a leap year. So February, they should have 28 days. Then the other day you have 30, either 30 or 31. So in a set, if you have the same numbers, you just keep one. The copy, the same. If you write 2 30s here, that's same with only has 1 30 here. So for the range, you can just write like this way. For the domain, that's this. We'll have 12 members here. For the range, you only have these 3 members here. So this one, A, that's a function. Now let's see B. B, A, positive integer. Input, that's positive integer. Output, the name of a month with the number of the days equals to the input. So now here, they give you this kind of inverse of the part A. You know, part A, they give you the month. Then they ask you what is the number in that month, right? Now here, they give you the numbers. Then they ask you the name of the month with that number as days equal to that number. Suppose I give you the 28. Then this year, suppose still 2005, then you know this one should be equals February. But if I give you 30, what is this month represent? So then you're confused, right? This one maybe it's September, maybe it's May, right? And maybe it's July. If I give you 31 days, this one is January, maybe March. So how you determine which month is? If we draw a plot, this one that'll give you, say I'll give you the days. If I give you like 28, then this one is fine. You find this one is February, because this one is February. Then 30, then you have trouble to determine which month it is. 31, you also have same thing. Like 25, you also cannot find any month respond to this input. Like 32, you also cannot find any month respond to this. So this one, you know, something will like this. Then when you draw a vertical line, suppose you draw a vertical line here, then you got more than one y values respond to this x. So that's exactly against the definition of a function. So this one is not a function, because for a same number, then you have maybe the more than one different value of y responds to it. So this exact example I gave you, you go to the supermarket, then they tell you this potato $1.5 a pound, also $1.8 a pound, maybe $2 a pound. So then you confuse. What price should I pay, right? If they do like this, that's meaningless. It's not logical at all, right? So by this way, that should not a function. So now let's say C, a positive integer, that's input, output, a perfect square that is less than the input. So now suppose I give you a perfect square. No, I give you a positive input. Suppose this one equals 5. Now you need to give me a perfect square number that less than this input 5. Less than this one, so we have 1 and 4, right? Less than this 5. 1 is less than this 5. 4 is also less than 5. But these two numbers are all perfect square numbers. So that means this one is not a function, right? Because we have an input 5, one input, then you give us more than 2 output, right? This one is not what we want, right? So then if you draw a vertical line at 5, then you got 2 output, 1 and 4. This one is not what we want. Now let's see D. Input is an integer. Output, the largest perfect square that is less than that input. Okay? So now if you input 5, say this y cannot respond to these two numbers. This y should to equals 4. Because the less than this 5, but the largest perfect square number, that's 4. 1 is less than 4, so we cannot count 1. So then if you give me a 10, then this answer will respond to 9 because the 9 is the largest perfect square number less than 10. So by this way, you cannot get the more than 2 output, more than 1. Now also for each number we have an output, right? So this one is a function. If this is a function, then tell me what is domain, what is the range. So domain for this problem, that's all this all the integer. You know, integer in math we use z to represent an integer. This included the positive integer and the negative integer, right? Then for the range of this function, this should be all the perfect square numbers. This one's are all the perfect square numbers. All the perfect square numbers. Okay? All the perfect square numbers. So now you understand the functions. Okay, now let's go to next problem. This one, 16.2. fx equals 2x plus 5. First one, find f1, f negative 3, and f positive 0.5. So this one is very easy. They ask you plug in these 3 numbers to get the value of this function. Now f1, that means you plug x equals 1, you get this one equals 7. This one equals 7. 2 plus 5. This one equals negative 6 plus 5. That's negative 1. 2 times negative 3, that's negative 6. Negative 6 plus 5, you get negative 1. Now this one, 2 times 0.5, that's 1. 1 plus 5, 6. Right? Now B, for what value of x does this one equals negative 3? So that means ask you solve this equation. 2x plus 3 plus 5 give you negative 3. Then they ask you what is x. To do that, both sides minus 5. You got 2x equals negative 8. So then both are divided by 2. You got x equals negative 4. So when x equals negative 4, then f negative 4 will equals negative 3. So then you can check. 2 times negative 4, you get negative 8. Negative 8 plus 5, you get a negative 3. Okay, very good. Now C. In terms of k, what is f2k? So when you plug x equals 2k, then what is the value for this function? You can do 2 times 2k plus 5. 2 times 2k, that's equals 4k. So 4k plus 5. This one's answer, right? Okay, now let's go to next one. This one asks you to still calculate this values function, this value. Then, but this function is a quadratic function. It's not a linear function anymore. So it's a little bit harder. Now let's see. When x equals 1, f1 should equals 2 times 1 minus 5. That's equals negative 3. This one equals negative 3. Then f5. When x equals 5, 5 squared, that's 25. 25 times 2, that's 50. 50 minus 5, 45. Then this one, x equals -3. -3 squared, that's 9. 2 times 9, 18. 18 minus 5, 13. Okay, now let's see B. Will all real values of x produce a value of fx? What is the domain of this function? So then they say, will all real numbers of x produce a value of fx? Yes. This x, you can choose any number you want, right? So that means the domain of this function just equals the real numbers set R. Usually in math, we use this capital R to represent all the real numbers. So the domain for this function equals R. C. Is there a real value of x such that fx equals 3? So that means you need to solve this equation. 2x squared minus 5. This one equals 3. Then both sides plus 5. You got a 2x squared equals 8. So then you got a x squared equals 4. So that means x equals plus minus 2. Okay, when x equals positive 2, you plug in, say, 2 squared, that's 4. 4 times 2, 8. 8 minus 5, you got 3. If x equals -2, -2 squared is still positive 4. 4 times 2, 8. 8 minus 5, positive 3. So that means this equation have two solutions. Now let's see D. Is there a real value of x such that this function equals -10? To get this one, definitely you need to solve this equation. 2x squared minus 5 equals -10. To solve this, both sides need a plus 5. 2x squared equals -5. Then you can say x always greater or equals 0. Then this one is a negative number. So if you continue solve this one, you get the -5/2. Then this one square root, and also positive negative. This one give you negative, the complex number, right? 5/2 square root, then times r. Then that means they ask you the real values. Definitely, this one's no real values. So the answer is no real values, right? For this case, you cannot find any real values satisfy this requirement. The answer for this one is no. What is the range of R? The range of R, so that means this one, because this one is greater or equals 0. So that means the value of this one always greater or equals -5. So then you can write range of this function. You can use set, that's -5, then positive infinity, right? You can use this set to represent. You can also use equality to represent. That means this one is fx. Then this fx should greater or equals 5, -5. You should write like this. You can also write like this. Okay? So now let's go to next example, 16.4. This one, they ask, consider the function fx equals 2x minus 3 divided by x plus 5. Calculate these values. This one now, it's a rational function, right? It's not a polynomial function. You know, polynomial function like linear function, quadratic function, this kind of function. So that's like ax power n plus bx n minus 1, this kind of function called a polynomial function. So like quadratic function, linear function, all belong to this polynomial function. But this one is not. This one you divided that's the two polynomial function divided each other. This one will not be a polynomial function at all. So at this case, now let's say what is the value for this three numbers. When x equals 1, then we got this one equals 1 times 2 times 1, 2 minus 3, that's negative 1. Negative 1 then divided by 1 plus 5, that's 6. So they got a negative 1 over 6. This one is a value for f1. Then second one, when x equals 1/3, then 2 times 1/3, that's 2/3, minus 3. Then divided by 1/3 plus 5. Then you simplify this. 3, there's 2 minus 9, that's negative 7. Then times this one simplified, that's 16 over 3. You know, divided a fraction, you need to change to multiplication, the flip of this fraction, or they call the reciprocal of this fraction. You divided 16 over 3. You can change this one times 3 over 16. Then you cancel out the common factor. You get this one equals negative 7 over 16. So this is the answer for f 1/3. You got negative 7 over 16. Then f negative 3. What is this one equals? You just apply negative 3 here. You get negative 6 minus 3. Then divided by negative 3 plus 5. So you got this one equals negative 9 over 2. So this equals negative 9 over 2. Okay, so now let's go to B. Are there any value of x that do not produce a value of fx? What is the domain of f? Yes, say when x equals negative 5, the denominator will equal 0. When x equals negative 5, this denominator will equal 0. In this case, this function will not produce a value for fx because the denominator cannot be 0. Then that means the domain of this function, that all other numbers except negative 5. We can write like this. Use this set united with this side. So that means in the real numbers, just take away the negative 5 away. This is one notation. You can use another notation that would be x belong to R and x is not equals negative 5. You can also write like this way. This is a domain. Now let's continue. In this part, we found the range of f. To find first find x such that fx equals 3. fx equals 3. That means you need to solve this equation, right? You get a 2x plus x minus 3 over x plus 5. This one equals 3. Then both sides times this x plus 5, you get a 2x minus 3 equals 3x plus 15. Then both sides minus 2x, you get a negative x minus 3 equals 15. So both sides plus 3, you get a negative x equals 18. So that means x equals negative 18, right? This one, you just solve this equation. That's No problem. Now let's see, is there a value of x such that fx equals 2? If x try to equals 2, that means we need to solve this equation. 2x minus 3 divided by x plus 5 equals 2. So then both sides times x plus 5, 2x minus 3 equals 2x plus 10. So then both sides minus, the left side you get 0 minus 3, then equals 10. So left side that's equals negative 3, right side equals 10. This one will never happen. It's not possible, right? So that means fx should not equals 2, right? So what happened here? Why fx should not equals 2? Now, to find this secret, we need to find the inverse function of this one. That means we need to use solve y. Then in term of solve x in term of y. To do that, now let's do this. Suppose this one is change this one to y. Then you solve x. To do this, both sides times x plus 5. You get x plus 5 times this y will equals 2x minus 3. So then you expanded this one, you get a y times x plus 5y equals 2x minus 3. So then now let's merge the term with x. So that means both sides minus 2x, get a y minus 2. Then parentheses times x. Then both sides minus 5y, get a negative 5y minus 3. Then both sides divided by y minus 2. Get this one negative 5y. This negative 5y minus 3, then divided by y minus 2. So we can also write this one as 5y plus 3 over 2 minus y. So we take this negative out, get a negative times parentheses 5y plus 3. Then we multiply that's negative to the denominator. So get a 2 minus y. So from this expression, you can see here, y should not equals 2. If y equals 2, then the denominator equals 0. That's meaningless. That's the reason why fx should not equals 2. So then from this, after you do this, then you found the range of this function that's from negative infinity to 2. Then united from this 2 to positive infinity. This is one way to write your range. Another way you can just do this, fx belong to R and fx is not equals 2. Okay, these two ways, they're equivalent. This one, that means you need to take the 2 away from this range. Otherwise, you have denominator equals 2. That's meaningless. So now you got how to find the domain and the range of a function. Now let's go to the next example, 16.5. So this one, we can place special restrictions on the domains of the function we define. For example, suppose we have function gx equals 3x minus 7, but define the function only for 3 less or equals x less than equals 8. For example, g2 is not defined. Then A, find x such that 3x minus 7 equals 0. Is your resulting x in the domain of G? Is 0 in the range of G? B, what is the range of G? Okay, so from this example, you will understand a lot of times we can just set the row. Then we'll, by this row, you get the different domain or range, all defined if this one is a function. Now, say this one, original, that's a linear function, right? We already learned for the linear function, domain and range are all real numbers. But here, they change this rule. They set a special rule, special restriction. See, that said we can place special restriction on the domain of function we define. For example, we suppose we have this function gx equals 3x minus 7, but define the function only for when limit x has to be between 3 and 8. So by this way, definitely x cannot equals 2. So that means g2 is not defined. When x equals 2, you cannot get the g value based on x equals 2 because x equals 2 is already out of this range, out of this domain, right? Now in this case, they ask you to find x such that 3x minus 7 equals 0. That means you need to solve this equation. So you got x both sides plus 7, you got 3x equals 7, then both sides divided by 3. You got x equals 3 over 7 over 3. 7 over 3. Now they ask you, is this your resulting x in the domain of range? Definitely no, because this number is equals 2 point something. It's less than 3, right? But the domain, it's here domain equals 3 to 8. Okay? Then all the other numbers outside of this interval is not in the domain. So this number is less than 3. So that means this number is not in the domain of G. Now they also ask you, is 0 in the range of G? Now let's see. Definitely looks wrong, right? If this one, when x equals what value can make this one? Say when 3x minus 7 equals 0, x should be equal 7 over 3. So that means no other value in the domain of range can make this function value equal 0. If you try to make this function value equal 0, x should equal 7 over 3. That's out of the domain of this function. So that means 0 is not in the range of G. So then they ask, what is the range of the G? The range of G just pre-built, because this one is a linear function. Just plug this boundary point, 2 points to here. Then get the range of this function equals, when x equals 3, 3 times 3 is 9. 9 minus 7, that's 2. When x equals 8, 8 times 3, that's 24. 24 minus 7, that's 14. 24 minus 17. 24 minus 7, that's 17. So the range of this function, that's 2 to 17. We also need to use square bracket because this one, this 2 points is included to the range. That is 3 and 8 is also included to the domain. So that's the reason we need to use a square bracket. Okay, so now let's go to next example. This one, 16.6, function need not have only one input. Suppose this function, they ask you what is f2, 3. That means x equals 2, y equals 3. To calculate this, you just plug in 2 times 2, then times 3, then minus 2, then plus 3. So this one, 4 times 3, that's 12. 12 minus 2, then plus 3. This one, you got a 13, right? So that means this function value equals 13. Now, suppose this function equals this. They ask you to find a if this one equals 15. Okay, so that means here, that's this variable, that should be a. So that's a equals 3. This one is b. b equals a. This one is c. c equals 5. See, that's reason based on this. This function variable, that's a, b, c. So then we can get 2 times 3 plus 3 times 8, because this variable now is 8. Then minus 4 times a, that's 3. c, that's 5. This one gives us 15. Now they ask you find a. So this 6 plus 3a minus 60 equals 15. So then we get a 3a equals 75, then minus 6, that will be 69. 75 minus 69, then both are divided by a, you got a 23. a equals 23, right? So then they ask you why this quadratic formula is not a valid function. Because for the same x, you got this plus minus, you got 2 different y. So this is not a function. So time is up. We can stop here. Your homework, that's all the exercise problem behind each section. Okay? So see